All right, students. This is the warm up. I recommend pausing. Um, I know pausing right at the beginning of the video. Recommend pausing and doing the warm up first, and then checking your answers. So I'll pause right here and let you try it. Okay. So now that you've tried the warm up and you definitely haven't just kept pressing play and writing down what I'm doing, uh, I want to know which of the following gives me f inverse of x. So to do that. All right, if you remember, we can do x equals 3 cosine of pi y. So I just, replace the x and y. So I'm going to divide by 3 first. So I'll get x over 3 is equal to cosine of pi y. And then what I have to do is I have to do the inverse cosine. So cosine inverse of x over 3 is equal to pi y. Uh, so I can get f inverse of x is equal to 1 over pi cosine inverse of x over 3. And the answer there is B, as in doorknob. Okay, so now I've got to go through these. So cosine of 5 pi over 2. Well, I know 5 pi over 2 is essentially one full rotation plus another pi over 2. So that gives me 0. Um, for this one, arc sine, kind of think of this as sine of theta is negative root 3 over 2. And if you remember, sine goes from negative pi over 2 to pi over 2. So we can say, okay, theta is, well, negative root 3 over 2 is when sine has the longer vertical side. So that's at negative pi over 3. So that'd be negative pi over 3. Tangent of 0, again, remember tangent, we're going from negative pi over 2 to pi over 2. And tangent sine over cosine. So if I think of this as tangent theta is equal to 0, really want sine theta to be 0 because that's in top. So that happens when the angle measure is 0. Negative 13 pi over 6. Okay, so for this one, first thing I'm going to do is I'm going to look at negative 13 pi over 6, and I'm going to add 12 pi over 6 because that's 12 pi over 6 is 2 pi. And I get negative pi over 6. Oh, coolio. So then that's cosecant of negative pi over 6, which I know negative pi over 6 is over here. And remember, cosecant is just 1 over sine of pi over 6. Um, and I know pi over 6, negative pi over 6, sorry, would be negative 1/2. So it's just the reciprocal of that, so it's negative 2. All right, so for cotangent of negative root 3, what I do for cotangent, again, I think of it as cotangent theta is negative root 3. So what I know is cotangent, right, is going to be this part. It goes from 0 to pi. And um, I know that I've got 3 options. And let's go ahead and think about it in terms of, like, we're going to ignore the negative for now. So I've got the pi over 3, and I know this is root 3 over 2 and 1/2. I've got my pi over 4 angle, pi over 4. You got root 2 over 2 and root 2 over 2. And I've got my pi over 6 angle, root 3 over 2 and 1/2. So then what I've got to remember is that cotangent of theta is the same as cosine theta over sine theta. And I look at these sides here, and I need to figure out, okay, which one of these when divided would give me just root 3. And then we'll come deal with the negative. Okay, so if I think of that, to get root 3, I would need, let's make that actually legible as a 3. I would need it to be root 3 over 2 divided by 1/2. So I need cosine to be root 3 over 2, which occurs at pi over 6. But since it's negative, I need to look over here, and that's at 5 pi over 6. So I know cotangent inverse of negative root 3 is going to be 5 pi over 6. That's how I do that. All right, so now let's go on to inverse trig, composites, and non-special angles. Cool. So what we're going to do today is we're going to still be using this information, and then we're going to look at uh, compositions. So like what happens when I take cosine of sine of an angle. So remember, when we do say like sine, the input here is an angle, the output is the ratio of sides. When I do arc sine, we're taking arc sine of the ratio of the angle, and that's going to give me, not the ratio of the angle, the ratio of the sides. That's going to give me the angle measure. So for arc sine or any, I can do arc tan, we put in a ratio, and we get out an angle. For any of the trig functions, so any of the inverse trig functions, cosine inverse of the ratio gives me the angle. If I did cosine, it would be cosine of the angle gives me the ratio. So first things first is when I see something like cosine inverse of sine of pi over 6. If you can't read, this right here says always start on the inside. So we'll start on the inside. So I'm going to deal with this part first, which if you think about the reason why we always start on the inside is just think back to, PEMDAS. We start with the parentheses. That's the inside part. So what I'm going to do first is I'm going to figure out what is sine of pi over 6. So I draw my little triangle. I know pi over 6 is here, and sine is going to be the short side. Remember, it's always over 1, so it's just the length of that side. So I'm going to have cosine inverse of 1/2. Okay, so now I need to figure out, okay, when is cosine 1/2? So this is when I was doing sine. This is when I'm going to do cosine. Okay. Um, so I need to figure out when is cosine 1/2? Well, it's when we're shorter here and root 3. So that happens actually at pi over 3. So cosine inverse of 1/2 is just pi over 3. And remember, right, when we're doing arc cosine, we're going from 0 to pi. And when we're doing, so this is cosine, cotangent, and secant. And then we're going from negative pi over 2 to pi over 2 for sine, tangent, and cosecant. Okay, so now we're going to look here at uh, cosine inverse of -2. Well, whenever I see cosine inverse or secant inverse, remember, I'm going to rewrite that as 1 over sine inverse of -2. And then I've got to think about when does sine, actually, that's wrong. I want to think of that not as 1 over that. I want to think of it as tangent of cosecant inverse of negative 1/2. All right. So what I want to do here is I want to think of this as tangent of sine inverse. And remember, that's -2. And sine is the reciprocal, so it's sine of negative 1/2. So we flip the inside part of the inverse part, the inverse sine. So I know sine theta is equal to negative 1/2. Remember, we're in this section, so negative 1/2 would probably be over here. Okay, so I look and it's going to be there when sine is the shortest side, and that occurs at negative pi over 6. So then I have tangent of negative pi over 6. And remember, tangent is going to be opposite over the adjacent side. So I get negative 1/2 over √3 over 2. I know the 2's are going to cancel. So I have negative 1 over √3, which when I multiply by √3 over √3, I get negative √3 over 3. And that is my answer. Cool. So now I want to do secant of arcsine of 1/2. Well, we just got done doing arcsine of negative 1/2, so I know, just remember, inverse sine is the same thing as arcsine. Well, I know that sine has a value of 1/2 at the angle pi over 6. So this is really the secant of pi over 6. And remember, secant is just 1 over cosine of theta is equal to secant. Okay, so then let's figure out what's cosine of pi over 6. Well, that's √3 over 2. So I know that secant is going to just equal 2 over √3, but then I've got to, rationalize. So I get 2 √3 over 3. And that's how I do this. Isn't that fun? Yay, math. All right. So for this one's a little different. It's not on the unit circle, as you can see here to the right. Right here. It's not on the unit circle. So what I'm going to do is, got to remember, we're looking on the inside first, so that's arc cosine, and it's a positive value. So I'm going to be looking in this quadrant right here. So I'm going to go ahead and make a triangle, kind of like we've done before. And I know sine is opposite over hypotenuse. So this is going to be 4. That'll be 5. And then I use Pythagorean theorem, and I get this side is 3. So then the next thing I'm going to do here is we're going to let theta equal sine inverse of 4/5. And remember here, right? 4/5, or the output of an inverse sine is the angle measure. So then I look here, I'm going to say, okay, let's do cosine. So I want to know actually what cosine of theta is. Well, cosine of theta is just, well, here's our angle. It's adjacent over hypotenuse. It's going to be 3/5. That's my answer. So my answer here is going to be 3/5. Oh, don't miss the part where I did it completely wrong. So that's fun. So we're going to look here. So the thing to remember about cotangent, right, is it's adjacent over opposite. So when I go to make my triangle, I notice that it's negative. So the other thing I have to remember about arc cotangent is we look at 0 to pi. And we're going to be negative in the second quadrant. So I'm going to draw my triangle over here, make that theta, because we're going to let theta equal arc cotangent of -3/8. Um, so if I remember correctly, it's adjacent over hypotenuse. So the adjacent, we have -3/8. So I know this is going to be 3, this is going to be 8, and then I need to figure out which one's negative. Since x is negative here, we'll make the 3 negative. Then I do Pythagorean theorem. So we get 9 plus 64 is equal to c squared. So c should be the square root of 73. So that's my hypotenuse. So now I have sine, and remember we let theta equal arc cotangent, so I can say sine of theta, and theta is opposite over hypotenuse. So I get 8 over root 73 multiplied by root 73 over root 73. And I get 8 root 73 over 73. Why is he saying it like that? I don't know. All right, example number 5. So we've got the arc cosine of 0.1, 0.25. Well, y'all, let's go ahead and let theta equal arc cosine, and I'm going to change it to 1/4 just because that'll be an easier thing to deal with when I'm making my um, triangle. And remember, just like cotangent, arc cosine, we look from 0 to pi, and cosine is positive in quadrant 1. So I'm going to make a little triangle here. Beautiful, beautiful triangle. We have the theta right there. And if I rewrite this as cosine of theta is 1/4, we know this is adjacent over hypotenuse. So I know the adjacent's 4, the adjacent is 1, the hypotenuse is 4, and I need to figure out what my vertical side is. Hey, we're going to use Pythagorean theorem. Shocker. So, oh, that was a big eraser. I don't know if I like the big eraser. So we'll do 1 plus b squared is equal to 16. So b squared is equal to 15. So b is root 15. It's actually plus or minus, but really, I should probably actually put the plus or minus here. But since we're in the first quadrant, I know it's going to be the positive one. So it's root 15. So, Mr. Otto, how do we know that root 73 is positive? The hypotenuse will always be positive when we're doing these. Okay, so now I look and I need to look at, okay, what is tangent of theta? Well, remember, here's our theta. Tangent is opposite over adjacent, so that's just root 15. Hey, look at that. Whee! Wonderful, wonderful. Okay, let's go to further problem now. We'll look at further problem. It'll be fine. It'll be great. Why are there X's in there? Good question. Let's figure it out. Okay, so love it. Love it when these problems are thrown in there. They're my favorite. So here again, let's let theta equal cosecant inverse of x plus 3 over x plus 1, which I could rewrite as cosecant of theta is x plus 3 over x plus 1. Um, so for these, I typically just write them so that I have, honestly, I just make a triangle. I don't really worry about where it's located. So we have our triangle. This is theta. And remember, cosecant is hypotenuse over opposite. So this is going to be x plus 3. This is going to be x plus 1. And then we've got to figure out what our adjacent side is. Super fun. So then I take x plus 3 squared. So I got to use Pythagorean theorem. Is equal to b squared plus, actually, let's go ahead and use a since adjacent does start with a, times x plus 1 squared. So I multiply that out. It's x squared plus 6x plus 9 is equal to a squared plus x squared plus 2x plus 1. Um, and then I just bring things over. I get a squared is equal to 4x plus 8. And I take the square root. So a is the square root of 4x plus 8. So I know this is going to be the square root of 4x plus 8. Whoa, cool. All right. So then I come back to my thing here, and I want to find cosine of theta, because remember this was theta here. And cosine of theta, well, it's just going to be, don't know what to do that. It's just going to be adjacent over hypotenuse. So it's root 4x plus 8 over x plus 3. So that's equal to the square root of 4x plus 8 over x plus 3. And now that's how we do that one. So cool. So now let's look at y-intercepts. Okay. So say this is our function that we're looking at, this thing right here, and we found an equivalent function, which is this, and we just want to find the y-intercept. Well, to do that, I, just plug in 0 for x, and I'll get square root of 8 over 3 when I plug in 0 for x, and that's 2 root 2 over 3. So my ordered pair would be 0, 2 root 2 over 3. So if you really want to see kind of what I was doing here, I did some stuff in my head. I did 4 times 0 plus 8 over 0 plus 3. What are the x-intercepts? Well, I just take that same equation, root 4x plus 8 over x plus 3. I set it equal to 0. When I multiply by x plus 3 on both sides, I'll end up with 4x plus 8 is 0. Square it. Go that way, and then go that way. And I get 4x plus 8 is equal to 0. It's just x is negative 2. So then there's ordered my ordered pair is negative 2 comma 0. Or my what's it called? X-intercept. Cool. So then what are the vertical asymptotes? Um well, first we got to look at where is the denominator equal to 0. So that's at negative 3. But I'm just writing that because I don't know why. The one thing we have to think about is if I look at negative 3, if I do my little number line here, be good to know what the domain is. So if I do my little chart for a domain, we already know that x is negative 2 when we have the 4x plus 8. We get the negative 2 from that. And so I know that works, and I know this doesn't. So I need to plug in some values to my equation. So if I did like, say, the negative 2.5, well, if I plug in negative 2.5 uh, to 4x plus 8, so root 4 times negative 2.5 plus 8 over negative 2.5 plus 3, what we notice is this part inside the radical becomes negative. So that's going to be larger than 8. And we don't want that. So we can't have a value here. Can't have a value here. Could I plug in a value over here? So let's do negative 10. If I plugged in negative 10, I'm checking the domain, that's not going to work. What about if I plugged in 0? That one does work. And so my domain here is negative 2 to infinity. So there are no vertical asymptotes. So that one was kind of a trick question. Wasn't that fun? All right, let's do this one right here. So again, just like always, I'm gonna let theta equal arctan of u minus 1, which means tangent of theta is equal to u minus 1. I'm going to write the over 1 just because I know this is what? Opposite over adjacent. So then when I make my triangle, beautiful, opposite is going to be u minus 1, adjacent is 1. And then I use Pythagorean theorem to find the hypotenuse, and I'll get u minus 1 squared plus 1. So that's u squared minus 2u plus 1 plus 1. So it's really just c is going to equal square root of u squared minus 2u plus 2. Because, I add those two together. So that's that. Isn't that fun? Minus 2u plus 2. Cool. So from there, I can figure out what secant is. So secant theta, remember secant is hypotenuse over adjacent. So I'm going to take the square root of u squared minus 2u plus 2 all over 1. So really, I don't need to write that, do I? Okay, well, it's gonna make me keep it. I don't want to keep it. So that's my thing. What are the y-intercepts? So to find the y-intercepts, I just plug in 0, and we get the square root of 2. So then that means my y-intercept is 0, root 2. Awesome. Well, now what I want you to do is try these on your own. Awesome.